Okay, so last set of notes for this chapter. Okay, so kind of what we've been doing, what we did on number 3. Okay, because we're going to kind of jump back in. We did about half of it, but we didn't finish the other half. Okay, so again, this is a this is a problem that I used to have on this test. This chapter test, this is one of the FRQs. I don't have it anymore. I have a different question because every once in a while I'll change up the questions, but it's a great question. And so that's why I put it in the notes, okay? So this is a great example of one. You can guarantee yourself that the next test we take, an FRQ is gonna come from this, okay? Because they're very popular, okay? Okay, so we have 3 things happening, right? Tide, we have sand on a beach, right? We have a beach, Sandy Point Beach. 3 things are happening. Sand is leaving the beach. The tide is pulling sand into the ocean, right? That's R of T. So the rate is R of T, okay? And then we have pumping station adding sand to the beach at the same time, okay? How fast is that doing? The rate is S of T. While this is both happening, there was sand to begin with. There was sand on the beach to begin with. How much? 2,500 cubic yards, okay? So what we did was we found how much sand will the tide remove from the beach during the 6-hour period. Well, the question said how much, right? How much is a total? Totals are the top guy, right? So that's why we had to do the antiderivative. So what we did was the antiderivative, or the integral, for the rate. R of T is the removal, right? So we did an integral from 0 to 6. It adds up all of the sand removed from the beach, and you get that. 31.816 yards cubed, cubic yards, okay? B we did, but then we stopped. So B says write an expression. So we have to create an expression or an equation. This is an equation because it has an equal sign. Write an expression or equation for y of t, okay? What is y of t? Y of t is the total number of cubic yards of sand on the beach at any one time, okay? So let's go through it. Why was there 2,500? Where'd the 2,500 come from?
The initial sand.
How much was already there, right? And then we did an integral. In plain English, what does S of t minus R of t mean?
How much is being added to how much is taken away?
Yeah, because at the same time as there's being added sand, S of t, there's being sand removed, right? And if you're trying to find the total of that, you got to use an integral, right? You got to integrate rate to get total. Okay, so anytime it says how much, or anytime it says what's the total, you're going to have to use an integral. You're going to have to use an integral, okay? That's the way to do that, okay? So part C says find the rate. So 2 things that are big, 2 things that are huge for this section is what do you know? What do you have? What do they give you, right? And what is the question asking of you? What is the question asking of you? Okay? So the first thing is, what is the question asking? So on that list over there, what is that asking for? The rate, right? So the second derivative is a rate of a rate. It's not what they're asking for, right? They're asking for the rate of a total. That's first derivative. That's right here. Okay? The rate for the total. Okay? So that's what we got to do. Okay? So we have a rate for a total. Okay? That's what the question is asking us to do. All right. So rate means derivative, right? Derivative of what? S of t, R of t, y of t? Derivative of what?
Is it S of t minus R of t?
Close.
Is it y of t?
It's y of t, right? Because it's the rate at the total amount of sand. What is the total amount of sand? That's y of t, right? That's what it says right here. Total. So we got to find the derivative of that guy. That will be the rate. Okay? So y prime of t. Okay, so let's find the derivative of the guy we just found. 2,500. What's the derivative of 2,500? 0. What's the derivative of this guy?
S of t minus r of t?
Yeah, there you go, right? Because it's the antiderivative of the derivative. You're just going to do the opposite, right? So it would be plus s of t minus r of t. That'll tell us the rate at any time that the total amount is changing. Okay? So we have time 4, right? So I'm going to go 4. So 0 plus s of 4 minus r of 4. So how do I figure that out?
Plug in the equations of S, like,
Plug it in where x is at any, where t is at any equations.
yeah.
Yep. So what's the easiest way to do that? Go for it. Calculator. Tell me what you get. Tell me what you get. Or I'll tell you what I got and then just... go with that. What units go with my answer?
Yard squared?
So it would be cubic yards, right? That's the total. But it's a rate. So it needs a time over time. Hour, yep. Per hour. Okay? That's my first question. My second, we got that. It's the total over time. So yards cubed over hours, right? Second question is, in context, what does that mean? What the heck does this question mean? Or answer, I should say.
Means that every hour there's 1.909 yards of sand getting taken away.
Close, you're close. Something about losing sand. Keep going. Close. You guys are getting closer. We're definitely losing sand.
Just how
4
much
hours,
sand?
we've lost 1.9.
After 4 hours, right? After 4 hours, more sand is being taken off the beach than being added, right? There's more sand being taken off than being added after 4 hours. Now, is that always going to be the case? I don't know. We haven't checked time 5, time 6. We haven't checked that. But after 4 hours, there's more sand being removed from the beach than being added. That's what that means. Okay, that's why it's negative. If it was positive, there'd be more being added. Okay? All right. Okay, so now let's go to part D. Part D is on the back. Same question. It's part of the same question. So for 0 to 6, so from 0 to 6, 0 to 6 hours, what is the number, what is the time t? At what time is the amount of sand a minimum? At what time is the amount of sand a minimum? And then what is that minimum value? So what are they asking for here? I know it says minimum, but we have different kinds of minimums, right? Shane, I got your focus over here. Yeah, can you please turn over your phone over? Thank you. Okay, what are they asking for? The minimum, but what does that mean? Okay.
when the rate of change is negative.
But well, how can I say this without giving the answer away? If you go look in your notes, you'll see the word minimum lots of times, and they're not always the same. Why not? So if you were to look in your notes, you'll see the word, especially last semester, you'll see the word minimum, 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 especially when we start talking about derivatives, right? But all the minimums aren't built the same. Why not?
But some of them are talking about like lowest value, right?
What is that called? Overall lowest value, what is that called?
Absolute minimum,
Or absolute minimum, right?
and then there's relative.
And then there's relative, right? Two different things. Even though they share the same name, people think they're the same thing. No, they're not, right? How we find them is different, right? Relative means a low point, right? Absolute minimum means the lowest point, right? Right? Think of your life, we have high points in everyone's life. We have high points and we have low points, right? Every day you go through highs and lows, right? It's just part of being a human. That's a relative, right? Good, not so good. Good, not so good, right? Absolute is like, this is the lowest point of my life. That's different than, oh man, I got a C on my test today, right? So that's the way I think about it. Lowest point or the highest point of my life. That's the best thing that's ever happened to me, right? Relative maximum means that's the best thing that's happened to me right now in the last few minutes or the last hour or the last of the day, right? That's the difference between them. They're very different things, right? They're very different things, okay? Which one is this referring to?
4.
Wait, minimums. This one's not a relative. This is a absolute. This is an absolute. Overall, from 0 to 6 hours, when was this amount of sand at its lowest, right? Absolute. Okay. And then what was that value? So when they say what is the minimum, they want to know that's the y value. They want to know the y value. Okay? How do we find absolute minimums or maximums?
Then we have to make a chart, X.
Yep,
Y.
that's part of the process. We make a chart, right? That's usually the last part of the process.
Finding critical values.
Find critical values, right? That's the first thing. So find critical values. Okay, so how do I find critical values? That's good. I like that. How do I find critical values? What did I do to find critical values? Set what equal to 0?
Y? Or not Y,
Which equation though? I have lots of equations, right?
Your total.
Close. What did I set equal to 0? Critical value.
The derivative.
There you go. The derivative equal to 0. Okay? Well, do I have an equation for total amount of sand?
Yeah.
What is that?
2,500.
That's y of t, right? So what they want is where is this equal to 0? That's what they want to know. Where is that equal to 0? Well, do I have, first of all, let's start with y prime. Do I have y prime?
Yes.
I do, right? What was y prime?
0 plus R of t minus S.
Yeah, so pretty much it was 0 plus, right? But pretty much it was just r of t, or was it the opposite? No, it was s of t minus. Yep, those are reversed. S of t minus r of t. Okay? So that's first thing. Second thing is, where is it equal to 0? Okay, so what does that mean? 0 equals s of t minus r of t.
That means,
Well, they're exactly the same. Where are s of t and r of t exactly the same? Okay? Well, usually we'd set the two equal to each other, right? Usually we'd set those two equations equal to each other. Problem is, not a problem, it's actually an opportunity. We can use calculators, and these are pretty crazy equations. I don't want to have to solve them by hand. So I'm going to use the calculator to do that, okay? The easiest way to figure out where two things are the same is by graphing them. So this part I'll show you because we haven't done graphing yet on the calculator, okay? So go to the calculator. So watch before you do. What I find is sometimes you get lost because you're trying to do this. You're trying to go up and down and you get lost. Watch and then do. Okay, so watch me do it and then you do it. Okay, so just watch right now. Okay, so to graph Big Shock, we're going to the grapher. Okay? Two things I need to graph, right? Two things I need to graph. First thing I need to graph is S of t. Okay, so I'm going to hit enter. And then I'm going to put S of t in there, right? S of t is 15. Let me use division first. 15x over 1 plus 3x, right? Next thing I'm going to put in is r of t. R of t is a little bit longer, and it's got 1 plus 5 sine 4, oh wait, division in there, 4 pi t over 25. Okay? All right, so I want you to do that. Do that and then look up here. First step. Put both equations in the grapher. So if you're not sure, start at home. The home button gives you all the different applications. Okay? Hey. Macy, yeah.
X is right here.
We could look at the graph as a picture, that's the graph, or we can look at a table. Okay? Just depends on what you need. So scroll up and over, hit graph, stop. Up, over, graph, stop. You should have these two. One's red and one's green. Or one's red and one's blue. S of t is red, R of t is blue. Okay? Hey, come on, come on. Let's see. I don't need the key. I don't need the key. I'll have someone lead me in. So just give that back to Pam. Thanks. See you guys later. Okay. All right. So now we don't care about this whole graph. I don't care about the whole thing. I just care about a very specific part of it, right? I only care where x or t goes from 0 to 6, right? See, it goes 8, 16, 24, -8, -16. I don't care about all that. So what I'm going to do is I'm going to zoom in. So to zoom in, you just get your, let's see. Just kind of see it right here. I'm moving over. I'm the little red dot there. I move over, and then right when you get to a spot that you like, hit enter. Oops, not the enter. Oops, back. Okay, wait, let me see here. There we go, navigate, okay. So instead of that, go up to, see where it says navigate? Scroll over to navigate. And if you want to zoom, it's plus, addition. If you want to zoom in, so we want to zoom in, right? And then you can use the arrows to move around. So I want to zoom in, zoom in. That's good enough right there. I could zoom in again, but I kind of, let me try zooming in again. Plus, there we go. And if you want to exit that, just hit the back arrow right by the OK. Now you're back to where you were. Okay. So from 0 to 6, we want to know what? What do we want to know again? Remind me again. We want to know Say it again.
Critical values
Critical values. And critical values are
when they're intersecting together.
when they're intersecting, right? When they're intersecting from 0 to 6. You can kind of see one right there, right? That's an intersection from 0 to 6.
5.117.
So to get that number, we're going to go back up and go to calculate this time. We're going to go up, back. We're going to go to where it says calculate. And we want to calculate where the red and the blue intersect. Nope, I hit the wrong button. Let's see. Oh, yeah, sorry. And then we want to pick one. That's correct. We want to pick one, pick either the blue or the red. And then we want to go down to where it says find. Remember, watch before you see, because if you try to do the same thing, you're going to get lost. So watch. Intersection. And then it does it for you. Okay, so one more time. Watch me do it one more time, and then you guys can do it on your own. Okay, so you're here. Go up to where it says calculate. I'll use the other one this time. You can use either one because we're just looking for where they intersect. Then you go to find, intersection, boom. It'll tell you anywhere in your screen where they intersect. They only intersect once in the screen. They intersect all over the place before and after, but I only care from 0 to 6. Okay? And then it tells you it's a little black dot there, and it says X is 5.117865, and Y is 4.694257. Okay? So jot that down, and we'll see what we can do with that guy. Okay, so 5.117865, and then 4.694257. Okay. All right. Okay, so now let's go back to our notes. Because all we were looking for is where they cross. Where are they the same? Which one do I use? Here's the question. Which one is my critical value? Because that's what we're looking for, right? Which one is my critical value? The 5.117 or the 4.6942?
5.117.
Because it's the x value, right? Or t, right? So t is 5.1179, I'll say. Okay. Okay, what do I do now? So now I found my critical value. What do I do with it?
Log it in, or put it on there.
Put it on the table, right? Because this is t, time, and this is the y of t, not y prime. Okay? What other values do I put on my table for absolute minimums? Starting and ending, right? So what's the start of the interval?
0.
The 0. What's the end of the interval?
6.
There you go. Whichever y value is the lowest, you got your minimum. Whichever y value is your highest, you got your absolute maximum. So how do I come up with these guys now?
Plug them in.
Plug them into your calculator. Plug them into your calculator. What am I going to plug them into?
The
The original equation.
Which is, what was the name of it?
The
Y of t.
Y of t. Y of t, yep. Okay, y of t. So plug them into y of t.
do, you gotta plug it into y of t.
Calculation. Okay, so y of t, I'll do the first one with you guys and then I'll let you guys do the rest. Okay, so y of t started with 2,500. That wasn't in the integral. Plus, then the integral came, right? The integral's in the toolbox where it says paste right underneath OK. It's in the toolbox. Go down to calculus, go down the integral, third one down. Y of t said 0 to t. So the first one I'm going to check is, the first one on my list is 5.1179, right? So I'm going to go 0 to 5.1179. Y of t was S of t minus R of t. Okay, but my calculator doesn't know what the heck S of t and R of t are, so I got to put those in. So S of t was 15x over 1 plus 3x, parentheses, minus R of t. R of t was a little bigger. 2 plus 5 sine the sine of 4 pi x over 25. Close parentheses, and you're done. 2,492 and then 0.36369. 2,492.369. Put that on my table. Okay. Now you're going to do the same exact thing, but what's going to change on the second one? The bounds, right? The only thing that's going to change is the bounds.
Wouldn't the second one be 0 though?
Yeah. So remember, cut and paste. Just go up to what you want to cut.
No, I mean, it would equal 0, wouldn't it?
Yeah.
Oh, okay.
So then you go up. I just want to change the bounds. To 0. So yeah, the whole thing won't be 0, just the integral part. The integral part will be 0. Okay?
2,500?
So just be 2,500, yeah. Okay, now do 6.
How come we're plugging it into y of t instead of y prime of t?
What is y prime of t?
The rate of change.
So do I want to know at what time the rate of change?
No.
I want to know at what time was the amount. And the amount is capital F, integral. If I wanted to know the absolute value of the rate, or sorry, not if I wanted to know the absolute minimum of the rate, then yeah, I would do that. But I want to know, it's asking for the absolute minimum amount. So that, yeah. That is y of t. I should put that there. Y of t. So you're going to get something close to the first one, very close to the first one. 2,493.28. So they want to know two things. They want to know what the absolute minimum value is. That's the y value. And they want to know at what time did it happen. Okay? So which y value is the smallest? They're pretty close together.
5.1179.
So yeah, that guy right there, the blue check, is the absolute smallest. Okay, so that's what I put. The absolute minimum value is 2,492.369 cubic yards at T equals 5.1179 hours. So again, you've done problems like this. You did problems like this last semester. What's the absolute minimum or the absolute maximum? And the only difference is now we have integrals as well. That's why they let you use the calculator. Last semester, they didn't let you use the calculator. You had to do it all by hand. This semester, they're like, yeah, they're having to do integrals, so to speed up the process, we'll let them use the calculator. Okay? So these questions that you see, you've seen before. You've seen before. Okay? All right. Okay, so we're going to skip the next one. We'll come back to it, but I want to do one that's kind of like this. So go to number 5. Go to number 5. Should be on the next page. 2 pages. Number 5 is very similar, so I want to do another one that's very similar. Okay. A tank has 5 liters of water in it at time 0. Water begins to be pumped into the tank at time 0. A different pipe is draining water from that same tank starting at time 0. The water is being pumped into the tank at a rate modeled by H of T, where H of T is liters per hour. Water is being removed from the tank at a rate by the function Z of T, where Z of T is liters per hour. What is the maximum amount of water in the tank from 0 to 5? Okay, so first question. What do we know? What do we have?
The initial is 5 liters of water.
Okay. What else? Is that all we have? We just know there's 5.
H of T is being pumped into the tank.
Kind of. So what does that mean, being pumped into the tank? H of T is being pumped into the tank.
It's providing water to the tank,
Just adding.
or adding water to the tank.
Okay.
And
So does that tell me the amount? What does that tell me?
The rate,
The rate. There we go. Now we're using buzzwords. I like that. The rate, right? H of T is being pumped into the tank. So this is the tank, 2 pipes, one leading in, one leading out. H of T is the rate at which water is moving in.
And Z of T is the rate where water is being removed.
There you go. Water is being removed from another pipe. That's Z of T. And then we said there's 5 liters, right? 5 liters in the tank currently at the start. Now it's important to know that the H of T and Z of T are rates. That won't always be the case. Look at example number 6. They give you G of T and P of T, and only one of them is a rate. Okay? So it's always important to know what they're giving you. So they're giving you rates. So H of T and Z of T are right here. We're right here. So if I want to know if they're asking me anything about total, I got to do an integral. Okay? Okay, so we didn't. So that's what we know. That's everything we know. What do we need to know? What is asking of me? What is the maximum amount of water in the tank from 0 to 5? So what is that? What is that?
bounds are 0 to 5.
From bounds are 0 to 5. So it's only 5 hours, right? 5 hours that this is happening. What is it asking of me though? What is it asking me from 0 to 5? There we go. Absolute maximum, right? They want to know what was the biggest amount of water during that time. So it's essentially the same question we just did, but it's not talking about sand, and it's not talking about minimums, absolute minimums. It's talking about absolute maximums, but they're the same thing. The only difference between absolute maximums and absolute minimums is the last step. We just look for the biggest instead of the smallest. That's the only difference. Everything else is exactly the same. Okay? Okay, so remind me, what did we do for the last problem? How did we find, what was the first thing we needed to do?
We set it equal to 0.
We set something equal to 0, you're right.
We have to
It's
make an
the-
equation.
So yeah, we don't have y of t, right? We need a y of t. Y of t, what did y of t tell me in the last problem? The total amount of sand on the beach at any one time, right? Well, this y of t is going to tell me the total amount of water in the tank at any one time. So it's going to start with 5, right? Because 5's already in there to start with, so 5 plus
Bounds of 0 to 5.
integral from 0, not to 5, I'm going to go to t because this is just the generic one that I can plug in. I'm building it. So it's going to be pumping in minus pumping out, right? So h of t minus z of t. Good. dt. Is that what I said equal to 0?
No,
No.
you gotta find the derivative.
So I got to find the derivative, right? So I need y prime of t. What is y prime of t going to be?
18.
Yes, h of t minus z of t. So now I have to figure out where that equals 0. That'll be my critical values, right? How do I do that?
Using the graph.
Using the graph on the calculator, okay? So now you try it on your own. Tell me where they cross from 0 to 5. So where do the two graphs cross from 0 to 5? It's good practice for your calculator. I don't care where they cross after 5, x is 5, or before x is 0. I could care less. I just care about where x is 5 and y is 5. Or sorry, where between x being 0 to 5.
Negative 1.51. Was it 34?
So is that where x? Yeah, that's before 0, right? Negative, you said negative? So we don't want that guy. We want in between. Is there anywhere in between 0 to 5 where they...
1.4617.
That sounds like a guy we could use, right? That sounds like a guy we could use. So would you say it one more time?
1.4617.
I got something a little different. Let me double check. I got something a little different. Let me double check. I got like 3 point something. Where's my cursor? There we go. Okay, so let me double check. I could be wrong. I just want to double check. Let's see. So we go to Grapher. Go back. Just use the back arrow until you get to where you want. Oops, went too far. So you just clear it.
I did. I put my decimal wrong.
Oh, okay. So the first one was, doesn't matter which order you put them in. You could put h of t first. You could put z of t first. So -8 parentheses 0.73 parentheses to the x power or t power plus 13. Okay. The next one was 4 parentheses 1.3 parentheses to the x power, and that's it. Yeah, that sounds right. 3.671, that's what I got, yeah. So again, I want to know, so I'm going to 0 to 6, let's see, I'm going to navigate minus So I can see they cross there and they cross here. Negatives I don't want. Positives I want. Okay? So I'm going to go to, need to go back, calculate, pick one of them and say intersection. So it gives me the first intersection's negative 0.56228. I don't care about that one. So I'm just going to scroll to the right, and that'll take me to the one I want. 3.671343, comma 10 point, right? So six, 71343, 10.48, 058. And I believe that's the only place they cross. Yep. Okay. Got all I need from the graph. Go back to your table. Okay. Again, which one do I want, the x or the y?
The X.
So 3.671, we'll say. Okay. Then we built our table. T, y of t, because we want the maximum amount, not the maximum rate, the maximum amount. Okay. So we're going to put in our critical value. We're going to put in the start and the finish. Okay. So now we got to plug them back into y of t. Okay. So just to save time, when you plug in 3.671, you get 10.612. When you plug in 0, you get 5. And when you plug in 5, you get 8.488 when you use the calculator to plug those in. So we want absolute maximum. So we say absolute maximum is 10.612. What was it? Liters, thank you. Liters. When T equals 3.671 hours. And we are done. Okay. So here's the thing. They won't always be talking about sand on the beach. They won't always be talking about a water tank, right? They mix it up, but you just got to understand, oh, this is total amount, right? So when they see those buzzwords, total amount and all those good things, that's what they want. That's what they want. Okay, so let's go to number 6. We'll do number 6, and then tomorrow we'll come back to that graphing one. It's the same type of problem, but it's a graph. They give you the graph, okay, so you don't have to use the graphing calculator. Okay, so we got another water tank.
The initial is 150 liters.
All right, so I'm going to build my picture. Oops. Yeah, so it's not always going to be water in a tank, sand on a beach. I think one of the questions I've seen before on tests is people leaving and entering an auditorium. People leaving and entering, I think it was Disneyland. There's the rate of people coming into Disneyland, the rate of people leaving Disneyland, things like that. But it's the same problem. It's just different context. It's always going to be something leaving and something entering. Okay. Okay, so the tank has 150 milliliters, or liters, sorry, as we speak right now, at the beginning. Water is being pumped into the tank. Water is being pumped into the tank, right? And water is leaving the tank. So water is, and then leaving, right? Okay. Water is being pumped into the tank at a rate of G of T, which is measured in liters per minute. So this is minutes. Okay, so leaving the tank, right? Or being pumped in, right? So this is G of T here. The total amount of water in liters that has been removed from the tank T minutes after the pump is turned on can be modeled by the function. How is that different than every other problem we've done thus far?
It's like the water in the bottle rather than the water actually coming out.
Yeah, it has nothing to do with the rate, right? Exactly. It has total, right? This guy, they're used to giving us rates and we need to go up. This one, they're saying, hey, you know what? Don't worry about it. I'll give you the total. So if you want to know anything about rate, I can't use P of T. I have to find the derivative and then do that. If I want to know about the total, yeah, go ahead, use P of T. So that's where it's a little different. Okay? It's not a rate, it's a total coming in. It's a total that's been removed. Okay? So what is the total amount of water in the tank at T11? So they want to know what the total amount of water is. How do I do that?
Make an equation first.
First thing, make an equation. I like that. We'll make the equation, then we'll stop for today. We won't go any farther. The hard part is making the equation because this one's a little bit different. Okay. Kind of like the others, but kind of a little different. So we'll call it Y of T. We've been calling it Y of T for the total, right? Y of T is total. Okay, so what do we have to take into account of?
The rate of change?
Before that,
The
the total that's already there, right? 150 plus. No, you're getting there.
It's kind of like the same thing.
It's kind of the same thing, but what's different?
We don't have to do the integral of P of T.
There you go. But we do have to do the integral of
G of T.
G of T. So which one's being subtracted? Is it G minus P to figure out the total or reverse?
G minus P.
So G is going in, right? Do we have to find, if I want to find the total amount that's going into the pipe, into the tank, do I need to do an integral for G of T? Yes. Okay, so let's set that up. Integral G of T. If I want to find the total amount leaving the tank, do I have to do an integral of P of T? No, right? So that's where it's changed. Minus P of T. I don't need to do an integral for P of T because they've already done that for me. Okay? That's the equation that we're going to use to solve it. Okay? And we'll do that. We'll finish that tomorrow. All right, guys?